The following video shows an activity where students are measuring the free fall of objects due to gravity using videos that they've gone and made, and then uploading these videos to a nice piece of software called Video Point. Video Point is not freeware, it's actually provided by Pasco, who also make data loggers, and one has to purchase the software from Pasco, from the company Pasco. To start the process, students have to make their own video. Students do this either using their iPhones, using their digital cameras, or bringing in using their own video cameras. In this example, a student called Dan has done this using his very nice digital camera that he brought in. In the video you can see there's the student Dennis here and the student Adrian. Dennis is holding the meter ruler because he has to provide calibration for the movie. We'll explain this later on. And Adrian's going to drop the ball. So the first thing students do is they take the movie, and this is the movie. Once they've done this, students then upload their movie onto Video Point. Before they do this, they have to trim the movie because there's a bit of garbage before and after, and they do this using a piece of software called Video Point Capture. So if I play the movie here, you can see Adrian dropping the ball, and it's being trimmed at the start and the end. Once they've done this, they then go through the following tabs that are very, very easy to use and manipulate. First thing they have to do is they have to calibrate the movie. This is where the meter ruler comes in, and we have to show that the movie, or give the movie an idea of the dimensions that it's dealing with. So this meter ruler gives the pixel dimensions for the video point. Once this is done, then they have to set up their point of origin. This is going to be Adrian. Adrian is dropping the tennis ball, so this is going to be the start point. Once they've done this, they're then going to collect the data. You can see at the top here that there's 18 frames inside this movie. Down here, there are 18 dots. Each of the 18 dots marks the position of the tennis ball. Students will then play the movie frame by frame and mark the position of the tennis ball as it goes, and as one expects, the tennis ball is moving further and further apart as it starts to fall inside the gravitational field. Once this has happened, they can plot the data. They can change the axis of this, and they can change acceleration, they can change to velocity, and they can change to this graph, which is the most appropriate graph, which is showing the position of the tennis ball with reference to time as it's being dropped in a vertical position. What we'd like to do with this now is, instead of using this piece of software to actually analyze the data they collected, we'd like students to use their own methods of data collection and data presentation and graphing. So the most obvious piece of software for this is Excel. Therefore, students will export this file using a text-based file and open it using Microsoft Excel. This is a piece of work that Adrian and Dennis have done on Excel, and you can see that here we have 18 frames, here we have time, X, Y, distances. If we look at the second graph, this piece of work is incomplete at the moment, but if we look at the second graph, we can see the similar trait to the graph that was actually collected inside Video Fundamentals. What Adrian and Dennis have gone and done is they've actually gone and modified their data, and they've gone and changed their time values into time squared, which is represented on this x-axis here on the first graph, and they've gone and multiplied their height values, which are the x values, and these are plotted on the y-axis here. If you look at this, they have a trend line, and from the trend line you can see that they've gone and got a constant value of minus 11.48. This is very, very close to what we would expect as gravity being 10 meters per second squared. So what this piece of software allows us to do is it allows us to take a real-world application, such as dropping tennis balls. It allows students to film the tennis ball. It allows students to manipulate the data to collect the data, and then put it all together like Dennis and Adrian have done here. Obviously, this piece of work isn't finished yet. There's no error analysis, and there's no bells and whistles, but we can see from this video that this is a very, very nice way of actually putting this lab together, and a way of measuring gravity using modern day technology.